November 2020, NSC, Eastern Cape, grade 10, maths, paper 1. So for question 1 and part 1.1, we're asked to factorize the following terms. So for this first one, 1.1.1, I've got 4y squared minus 16. And the first thing to notice is that I've got a common factor of 4 in both of the terms. So I'm going to take out a common 4, and I'm left with y squared and 16 divided by 4, which is 4. And now I can see that in this bracket, I've got a perfect square in the first term and a perfect square in the last term and a negative operation sign in between them. So I can use the difference of two squares to further factorize that bracket. So I'm going to keep the 4 the same. And in my difference of two squares, the rule is that I square root the first. So I'm going to have one bracket becoming two brackets. And in the first bracket, I'm going to square root the first term, which is the square root of y squared is y. And I will have minus the square root of the second term, the square root of 4 is 2. And then in my second bracket, I'm going to have the square root of the first term again, y. And now I'll have a plus, a positive sign, and the square root of the second term, which is 2 again. Okay, and if you want to check that you've done that correctly, you can go back and multiply all of these things together. So I'm going to start with the brackets, and because I've got two brackets and two terms in each bracket, I can use FOIL to multiply them together. And so the first term is going to be the product of the first two terms in each of the brackets. So that's going to be y times y, which is y squared. And then I'm going to have the outer terms multiplied together. So that's going to be y times positive 2 is positive 2y. The inner terms multiplied together is going to be negative 2 times positive y, which is negative 2y. And then my final term is going to be the last two terms multiplied together. Positive 2 times negative 2 is negative 4. And I've still got the 4 on the outside here. And then in the bracket, I can see that the positive 2y is going to cancel out with this negative 2y. And so my bracket, still keeping the 4 on the outside, the bracket is now going to be negative y squared minus 4, which is what I had the first time that I factorized it. And now I'm going to take it all the way back to the beginning and distribute the 4 back into the bracket, and I will be left with 4y squared minus 16 as expected. All right, then for the next question, 1.1.2, I've got a fraction, and the first one, the numerator I can see is the first term is a perfect cube, x cubed, and the second term is a perfect cube as well, which is 1. And so I can use the difference of two cubes. So the difference of two cubes, I know I'm going to get two brackets. One of them is just going to be two terms. And then the second bracket is going to be three terms. And it's going to be a quadratic expression. So I'm going to have an x squared, a something x squared, and then an x term, and then just a number at the end. And I know the rules for the signs. So if I've got that the sign of the original expression was negative, like I've got here, then I know that the sign in the first bracket is always going to be the same. So I'm going to have a negative in the first bracket. And then for the second bracket, the first sign is going to be the opposite of what the original sign was. So if I've got a negative here, I'm going to have a negative in the first bracket. But in the second bracket, the first operation is going to be a positive. And then for the second operation is always going to be positive as well. So I'm going to have my terms in between these operations. And the terms for the difference of the two cubes, for the first bracket, I'm going to have the cube root of the first term. So the cube root of x cubed is x. And then I'm going to have minus. and then the cube root of the second term, so the cube root of 1 is 1. And then for my second bracket, it's going to be a quadratic expression, like I've said, and the first term is going to be whatever is here squared, so I've got x squared, and then for my second term, I'm going to have the product of these two things, so x times 1 is x, and then for my last term, I'm going to have this term squared, which is 1 squared is 1, and I'm going to keep my denominator the same, and I can see that my denominator and my this in the denominator and this bracket in the numerator are exactly the same, and because I've got no plus or minuses in between these brackets at the top, and I've only got one bracket at the bottom, I can cancel these two out. So that is going to cancel with that. And I am just left with the first bracket, which is x minus 1 over 1, which is x minus 1. Okay, and then for the next part, this 1.1.3, I've got 4 terms here, and how I'm going to solve this question, or how I'm going to factorize this expression, is by using grouping. So I'm first going to insert my own brackets here. So I'm going to put a bracket around these two terms and then a bracket around these two terms. Okay, and I want to get, so this can't be factorized any further. So I want to get this bracket to look something like this bracket, right? So I'm going to keep the first bracket the same, which is this x minus 1. And then I can see that I've got a common y here in these two terms. So I'm going to keep the positive outside, take the y outside that bracket, and I'm going to have 1 minus x. So now I can see that these brackets are almost the same but slightly different, because for this one I've got positive x, but here I've got negative x, and then here I've got negative 1, and here I've got positive 1. So essentially what I need to do is that the positive and the negatives in this one need to swap around so that it's going to be the same as the positive and the negatives in this one. So what I can do from this bracket is take out a factor of negative 1, right? If I take out a factor of negative 1 from this bracket, I'm taking out a negative 1 from the 1, and I'll be left with negative 1. And I'm taking out a negative 1 from this negative x, and I will be left with positive x, which is what I want, as it's going to be the same as this bracket here. Okay, so I'm taking out a negative 1, so my x is going to be positive, and then my 1 is going to be negative. Okay, and since I've taken out this negative 1 from the bracket, it's going to come here to the positive y, and my y is now going to be negative. And then this bracket is going to remain the same. So now I can see that these two brackets are exactly the same, and they are separated by a minus sign. So I've got two terms, this bracket and this y times this bracket, and I can take out the common factor, which is x minus 1. So if I take x minus 1 out of the whole expression, the first term that I'm going to be left with is 1 here, and then I am left with a negative 1 as the second term. And if you're unsure, again, you can use FOIL and multiply everything back out together to check that you did the right thing. So I'm going to have my first terms here multiplied together is x. My second term, the outer terms multiplied together is x times negative y. And so the product is going to be negative xy. The inner terms is this negative 1 times positive 1. So I've got negative 1. And then the last terms multiplied together are going to give me a positive y. Okay, and then just by rearranging, I can see that this is exactly the same as the expression that I had from the beginning. So I'm still going to have x at the front, and then I'm going to make this -1 be the second term. And then the third term was the positive y. And the last term is this -xy, which is exactly what I had from the start. So I know that my factorizing was correct. Okay, then moving on to the second part. Now we're being asked to simplify these expressions. So again, I've got a fraction, and I'm going to start with simplifying at the top. So I can see that I've got a common 3 in both of these terms. So I can take out my 3, and the bracket that I'm left with is 1 minus x. And then in my denominator, I've got a quadratic expression. And if I factorize that, I get that x minus 1 and x minus 2 are my two brackets. If you're unsure, again, you can FOIL these. So if I were to do that, then I would have x squared as the first term, minus x as the second term, minus 2x is the third term, and my last term is going to be positive 2, and that simplified is exactly what I had here. Okay, so that's just to check that you've factorized that bracket correctly. So now I'm moving on, and I've got the same thing as I had in the previous question, where these two brackets are almost the same, but not quite. So again, I've got a positive x in this one, but a negative x in this one, and I've got -1 in this one, and I've got +1 in this one. So if I want them to be the same, I'm going to want this x to be positive, and I'm going to want this 1 to be negative. So just like we had before, I'm going to take out a -1 from the numerator bracket, and which means that my 3 on the outside is now going to become a -3. And I've swapped the operations on the inside. So my +1 is now going to be a -1, and my negative x is now going to be a positive x. And I'm going to keep my denominator the same. And now I've got two brackets over each other which can cancel out. Remember, I can cancel out because there's no plus or minus. There's no plus or minus here that's separating these, for example, in these two brackets. So I can definitely cancel out these two. And what I'm left with is a -3 at the top and an x minus 2 at the bottom. And that's it, simplified. All right, moving on to the next one, 1.2.2. I've got fractions again, and now I've got exponents. And these are being multiplied together. So the first thing to notice is that in my denominator, I've got 3 and 4 being multiplied together, and 3 and 4 are both factors of 12 and 16. So the first thing that I'm going to want to do is make the bases of the exponents look the same, because when the bases are the same, then I can apply some certain exponent rules. Right, so starting with this first one, I know that 4 times 4 is 16, so that means that 4 squared is 16. So I'm going to have a 4 here and a 2 in the exponent, and I'm going to keep the same exponent that I had before for the 16, right? Because this is still 16, this 4 squared is still 16, and the 16 is still going to be raised to a -x. So that's going to be the first bit. And then I've got times 12, and I know that 12 is the product of 4 and 3. Remember, I'm looking for bases of 4 and 3 because I've got that in the denominator. So if 12 is a product of 4 and 3, then I can say 4 times 3, and both of them are still raised to this x plus 1. Okay, and then at the bottom, I have got the 4 and 3 that I was looking for anyways, so I'm going to keep these the same. So I've got 4 and then negative x. Now I want to distribute out the exponents. So this first one is easy. I'm just going to have these exponents multiplied together. So the term that I have is 4 to the power of negative 2x, and then multiplied here. Now when I've got, I'm going to write this like this. When I've got bases that are multiplied together, this exponent belongs to each of the bases. So this x plus 1 belongs to the 4, and it also belongs to the 3. So I can separate these out, and I've still got them as products. So I'm going to have 4 to the x plus 1, and then times 3 also to the x plus 1. And my denominator is going to stay the same again. So 3x here, and 4 to the negative x here. And now I can use my exponent laws. So I've got same bases of 3 here, and then I've got the same bases of 4 for these ones. Okay, so let's start with the 4s. So with the 4s, I've got this 4 that's being multiplied with this 4. And if I've got the same base and the same base, and I am multiplying this 4 with the 4, then the exponents are just going to be added together. So I'm going to keep the same base, which is 4, and then my exponent for the first one was negative 2x, and then I'm going to add the exponent for the second one. So I've got plus x and plus 1. Then I've got this third 4 that these 4s are being divided by, and my exponent laws say that when I've got the same base and the same base, and there's division, then it's going to be this exponent minus this exponent. So this exponent here is going to become positive, and I'm going to add it to this 4 base again. Okay, so just to clarify, I had 4 to the negative x2, and then I had the same base to multiplied to the power of x plus 1. So I'm adding this x plus 1 to the same base. And then I had the same base again, but now I have division of this 4 to the x minus 1. And so I'm going to have it added to the exponents that I've already calculated. So instead of having a negative x, I'm going to have positive x at the bottom. Okay, and then for my 3s, so I've got this 3 up here and this 3 down here. So this 3 is being multiplied by the 4s at the top, and I'm going to keep the same base, 3 and x plus 1, and this 3, because there's division, is going to be the negative exponent. So I'm going to have negative x for this one. And then I'm going to add and subtract all my exponents together. So I'm going to have negative 2x plus x is negative 1x plus another x is 0x. And so I'm just left with 1. So I have 4 to the power of 1 times 3. So I'm going to simplify these exponents as well. X minus x is 0x. And then I've got plus 1 remaining. So I've got 3 to the 1, which is just 4 times 3, which is 12. Okay, and then for the final part of number 1, I've got 1.3. And I'm given this expression for m is equal to x times x minus 2 raised to the 2. And it says find m if x squared, xy squared is equal to 4 and x cubed minus 2x squared y is equal to 3. So it looks like I'm going to have to distribute this x, well, first distribute the squared, and then distribute the x, and then I'm probably going to have terms in my answer that look like this and that look like this, and then I can use substitution to sub in 4 and 3. So the first thing I'm going to do is take this expression of m that I've got, and I'm going to expand it. So before I multiply in this x, I first have to deal with the exponent that's here. Okay, so that's BODMAS. You've got to start with this exponent before you do anything else. So with the exponent, I can either just use the difference of two squares again. So I will have x staying on the outside, and then I square the first term. I'm going to find the product of the two terms times 2 for my middle term. So that's going to be negative 2xy. And then for my last term, I'm just going to square that and I'll have a positive y. Alternatively, you can notice that x minus y squared is the same as x minus y times itself. And then I can use FOIL, and I'm going to have the product of the first two terms, the product of the outer terms, the product of the inner terms, and the last two terms. And then when I simplify that, I get x squared minus 2xy plus y squared, which is exactly what I have here. What I'd have in this bracket, this should be y squared. Okay, so now that I've sorted out this exponent, I can then go on and distribute the x inside. So I'm going to be multiplying every term by x. So x squared times x is x cubed, and minus 2xy times x is minus 2. X is squared, y stays the same. And then for the last one, I'm going to have xy squared. Okay, and then I'm going to go back to the original information that I was given. So I was told that this is equal to 4 and that this is equal to 3. And in my answer, I can see that this is exactly, I've got 3 terms that look exactly like this bit of information that I was given. So this is exactly this, which means that I can substitute this here just for the number 3. So the first two terms together is going to be 3. And then I can see that this here is exactly this here that they've given me in the question. So I can substitute that for 4. And then my final answer is just going to be 7. Okay, so moving on to question 2, the first part, 2.1, asks us to solve for x without using a calculator. So this question 2 is just some more algebra like question 1 was. So for the first one, 2.1.1, we've got x cubed equals 9x. All right, so I want to solve for x. So the first thing that I'm going to do is take all of my terms that have got x to the other side, or to one side of the equation. Okay, so I've already got x cubed here. I'm going to keep that there, and I'm going to take this 9x over to the other side, which means that I've now got x cubed, and my positive 9x is now a negative 9x. And the only thing that I've got left on the other side is 0. And now I can factorize. So I'm first going to take out a common x from these two terms, and I'm going to be left with x squared minus 9, still equal to 0. And now I recognize difference of two squares. So I'm going to have x, and my one term is going to become two terms. And in both of the brackets, the first term is going to be the square root of x squared. So I'm going to have x for this one and x for this one. And then the second term is going to be the square root of 9. So I'm going to have 3 for this one and 3 for this one. Then in one of the brackets, I must have a positive sign. And then in the other bracket, I'm going to have a negative sign. And then it's still all equal to 0. Right, so what this means is that the product of these three things is equal to 0, which means that either this one is equal to 0, or this one is equal to 0, or this one is equal to 0. So for x to be 0, we just have x equals 0. For this bracket to be 0, I have a positive 3 here. So to make this what I want to add to positive 3 to make it 0 is going to be negative 3. So for this bracket, if I want the whole thing to be 0, I need the x to be a negative 3, so that when I add it to the positive 3, I'm going to have 0 for the whole thing. So for that bracket, I can have x is negative 3, and then similarly for this one, I need x to be positive 3. Okay, so these are my three answers for x: 0, negative 3, and 3, that will make the product of these things equal to 0. Okay, so moving on to 2.1.2, I've got p equals 3 over 2x and a bracket inside. So the first thing that I want to do is I want to isolate x and kind of get it on its own. So what I can do is I can divide this p by everything that's multiplying the x. I'm going to keep the 3 over 2 with the x for now. So I'm going to have p divided by this entire bracket. So I'll have 3 over 2x is equal to p divided by px squared minus pq squared. Notice that even though these are both q, this one is a big Q and this one's a little q, so I can't cancel them out. They're not the same thing. Okay, so next I notice that in the denominator I've got a common p. These p's are the same, they're both capital. So I've got a common p with these terms, and I've got a p in the numerator. So it'll be really nice to cancel that out. So I'm going to take out a common p in the denominator, and I'm just left with this bracket, q squared, and I've got p at the top. So these two are going to cancel out. And then I'm still saying that this 3 over 2x is just equal to 1 over big Q squared minus little q squared. Okay, and now if I want to get x on its own, here I've got x being divided by 2. So if I want to get rid of that divide by 2, I'm going to multiply both sides by 2, which means that I'm going to have this fraction multiplied by 2, and I'm just left with 3x on this side. So I'm going to have 3x is equal to 2 times this fraction, and my 2 is going to go to the numerator. And I still don't have x on its own. It's still being multiplied by 3 on this side. So to get rid of the multiply by 3, I'm going to divide both sides by 3, which means that I'm going to get x on its own here, and then this fraction divided by 3. So I'm going to have 3 in the denominator. And I'm going to put my brackets back because this 3 is being applied to the whole bottom part of the fraction, the whole denominator. Okay, and that's my final answer. I've solved for x. Okay, moving on to 2.1.3. Now I've got exponents. So the first thing that I notice is that I have a common factor of 3 in both of these, so I can divide both sides by 3. And on this side, I'm going to be left with x to the 3 over 4. And 81 divided by 3 is 27. Okay, and because I've got an x to the exponents on this side, I want the stuff on this side to also be exponents so that I can so I can make them equal. So I'm going to keep this x3 over 4, and I want something that's going to have either a 3 or a 4 here, because I want the exponents to look similar. right? So I know that 27 is the cube root of 27 is 3. So I can write that 27 is equal to 3 to the power of 3. Okay, I'm just going to rewrite this. 3 over 4. Right, so now what I want is that I want x to be on its own. I don't want to raise to anything, I just want it to be x. And I know that when I multiply two fractions like this, right, this 4 is going to cancel with this 4, and this 3 is going to cancel with this 3, and I'm going to be left with 1, which is exactly what I want to happen in this exponent here. I want x to just be raised by the 1. So I'm going to raise this entire expression. I'm going to put it to the power of 4 over 3. And what I do to one side of an equation, I have to do to the other side of the equation. So this 3 to the 3 is also going to be raised by this exponent 4 over 3. So I'm going to have x and 3 over 4. And I'm going to multiply the exponent by 4 over 3 so that it cancels to 1. And then I'm going to have 3, and it was raised to 3, and now I'm going to have it multiplied by 4 over 3, because what I do to one side, I must do to the other. So on the left-hand side, I'm left with x to the power of 1, which is just x. And then I've got 3 being raised to this product, and 3 times 4 over 3. These 3's are going to cancel, and so I'm just left with the 4 in the numerator, and 4 over 1 is 4. So this exponent here is now a 4. So I've just got 3 to the 4, which is equal to 81. And so my final answer is that x is equal to 81. Okay, moving on to part 2. All right, this 2.2.1, we've been asked to simplify the following. So it was 2 minus 3x is greater than or equal to 15. Okay, so there's two ways that you can do this. I'm going to do the first by distributing the 3 into the bracket. So I'm going to have 3 times each term. So 3 times 2 is 6, and 3 times negative 3x is negative 9x, greater than or equal to 15. Then I want all my things with x on one side, and I want all of my constants, just the numbers, on the other side. So I'm going to keep this negative 9x here, and when I take x to the other side, 6 to the other side, it's going to become a negative 6. So I'm going to have that negative 9x is equal to 15 minus 6, which is positive 9. Then I want x to be on its own. Now, if I want x to be on its own, I've got to divide this side by negative 9, which means that I'm also dividing this side by negative 9. And remembering that when I've got equalities, so if I've got a greater than or a less than, when I divide by a negative number, the equalities have to change direction, and I keep the equal bit at the bottom. Right, so my equality is going to change direction. I'm dividing negative 9x by negative 9, so I'm left with x on this side, and then on the other side I'm dividing 9 by negative 9, which is negative 1, and so my answer is that x is less than or equal to negative 1. If you want to do it the other way around, so my original expression was this. This time I'm going to start with dividing both sides by 3, which is the common factor, and so I'm just left with this bracket, and 15 divided by 3 is 5. Then again, I want all my x's on one side and all of my constants on the other side, so I'm going to leave the negative 3x on this side, and then the 2 is going to go over to the other side. It becomes negative, so 5 minus 2 is 3. Then again, I'm dividing by negative 3, so my equalities change direction. I've got negative 3x divided by negative 3 is a positive x, and then 3 divided by negative 3 is negative 1, and I have the exact same answer as before. And in the second part of the question, we were asked to draw a number line to represent our answer. So I know that my boundary number is negative 1. So I'm just going to draw a number line. I'll have negative 1. You can put in 0 if you like. And I can see that my x is, first of all, going to be less than negative 1. So my line is going to go here for x. And I should add arrows to my number line. So I know that my x is going to be on the left-hand side of the negative 1, which means that it's less than. When it's on this side, it means that it's greater than negative 1 because 0 is here. So that means that the number is becoming bigger. But I want my x to be smaller than the negative 1. And then I'm going to have my dot here. And how I know if my dot is open or closed is if there is an equal to here on the equality. So because I've got that x is less than and equal to negative 1, I'm going to fill in my dot to show that. Okay, and I'll also put an arrow here to show that x continues forever in the negative direction. And then for 2.2.3, we are given a set of equations. So the first one was 3x plus 2y is equal to 13. And then the second one was 3x is equal to 2 minus y. And we are asked to solve simultaneously. Okay, so there's two ways that you can do this. So I'm first going to label these equations 1 and 2. Okay, the first way is that I can subtract the equations from each other. But to do that, I want them to have the same kind of format. So I'm going to want my variables all on one side. So this is way 1. I want my variables all on one side and my constants all on the other side. So equation 1 is already like that. And then for equation 2, I had 3x on this side. I want to take the negative y to the other side. It's going to become positive y. And then I'm just left with 2 on the side. Then I'm going to want equation 1 minus equation 2. And for that, I'm going to say 3x minus 3x, and then 2y minus y, and then 13 minus 2. So the answer that I'm going to get is that 3x minus 3x is 0x, and then 2y minus y is a positive y, and 13 minus 2 is 11. So now I've got my value for y, and I want to substitute that value back into one of my two original equations to also find the value of x. So let's say I sub it into equation y, and I always tell the examiner what I'm doing. So I'm going to sub y equals 11 into equation 1. And my equation 1 was 3x plus 2y is equal to 13. So 3x is going to stay the same. Plus 2, I'm now going to substitute in that y is 11 is equal to 13. And then I can just solve for x. So I'm going to take 2 times 11, which is 22, to the other side. 13 minus 22 is negative 9. And so x is equal to negative 3. Okay, and if you had subbed it into equation 2, you would have got, if you had subbed this y equals 11 into equation 2, you would have got the same answer, because 2 minus y, which is 11, you would then get negative 9, and you would have that negative 3 is equal to negative 9 again, and then you solve for x in the same way. Now, the second way that you could have solved the simultaneous equations is to find an expression for one of the variables in terms of the other variable, and then you substitute that into the original equation. Okay, so for example, I can choose that I want to express x in terms of y. So from equation 2, I have that 3x is equal to 2 minus y. In fact, it's easier to represent y in terms of x. So that means that I just want to get y on its own and equal to everything else. So if I start with 3x still on this side, I'm going to take the negative 2 to the other side. I mean the positive 2 to the other side, which then becomes a negative 2. And that's going to be equal to negative y. But I want positive y, so I'm going to multiply everything by negative 1. And I will have negative 3x plus 2 is equal to positive y. So now I've got an equation for y in terms of x. And I had used equation 2. So now what I'm going to do is take this equation 2 that I basically just rearranged, and I'm going to take the y, which is equal to this now, and I'm going to substitute it back into equation 1. So everywhere that I see y in equation 1, instead of writing y, I'm going to write negative 3x plus 2. Okay, so a reminder that equation 1 was 3x plus 2y is equal to 13. And now I want to substitute in this value that I found for y. So my 3x is going to stay the same, plus 2 is going to stay the same. Now instead of y, I'm going to have negative 3x plus 2 is equal to 13. So I've just put this value in there. Okay, and then I'm going to distribute my 2, so I will have negative 6x plus 4 is equal to 13. And then I'm going to simplify my x's on this side, so 3x minus 6x is negative 3. And then I'm going to take my 4 to the other side, which becomes negative 4, so 13 minus 4 is 9, and x is equal to negative 3. Then I've now got a value for x, and so I can substitute this value for x back into either one of these two equations, either one of my original equations, to find the value for y. So I'm going to choose equation 2. So I'm going to write sub x equals minus 3 into 2. And I remind myself that equation 2 was 3x is equal to 2 minus y. So everywhere that I see an x in this equation, I'm going to put negative 3 instead. So I'll have 3, negative 3 is equal to 2 minus y. And I'm going to take everything that isn't y to one side, and I'm going to keep the y on its own. So I have negative y on this side, and the 2 has gone over to the other side and become minus 2. So 3 times negative 3 minus 2. And when I solve that, I have minus 9 minus 2, which is minus 11, is equal to minus y. And remember that I just want y and not negative y. Then I've got that y is equal to positive 11, which is exactly the same as what we got on the side.